If you're connecting a telephone or an analog modem to your plain old telephone system or your POTS system, then you're probably using this RJ11 connector. This is what we technically call a 6-position 2-conductor connector. That means there are 6 places for wires inside of this connector, but we're really only using 2 of those conductors, as you can see in this cable, that it has this RJ11 connection at the end. You might find some of the RJ11 cables that you're using for your modem or your telephone actually have 4 wires inside of them with 4 different conductors. That 6-position 4-conductor is technically an RJ14 connector, but it has exactly the same connector on the end, and we often use these cables interchangeably. With a separate set of conductors or separate set of wires inside of this cable, we're able to use this single cable for dual line use for someone who might have 2 telephones on their desk. Here's the connection that is inside the modem or inside of the device that's connecting to this RJ11 connection, and you can see the 2 conductors that are inside of that connector when you plug in the RJ11 modular connector. A connector that's a little bit wider than an RJ11 is an RJ45. This is the type of connector you commonly see associated with a wired Ethernet connection. This is an 8-position, 8-conductor connection, which means we have all 8 of those connectors and all 8 of those wires that are being used inside of that cable. This is also similar to a format you might see called an RJ48C, which has an 8-position, 4-conductor. Those are commonly seen with T1 or wide area network connections. An RS-232 connection stands for Recommended Standard 232. This is a serial connection type that has literally been around since 1969. And it has been around so long because it's able to connect to so many different kinds of devices. Before there was USB type connectivity, we commonly used RS-232 to connect our mouse connections, our printers, our networks, and other devices as well. These days, RS-232 is commonly used as a configuration port on a switch or a router or a firewall, and it's plugging into a serial interface on a laptop or another computer. The 25-pin version of RS-232 is usually referred to as a DB25. This 9-pin connection, which is a bit more modern, you'll sometimes hear referred to as a DB9, but technically it's the smaller style of D subminiature interface, which is the ESI. So you may see this 9-pin connection being referred to as DB9 or DE9. It's really referring to exactly the same connection. A very common type of coaxial cable connection is a BNC connection. The B in BNC stands for bayonet, which is the style of cable that plugs in and then twists to lock. And you can see the locking mechanism on the cable right here. The N and the C in BNC stands for Paul Neal, who is at Bell Labs, and Carl Councilman, who is at Amphenol. They designed this particular connection and called it the BNC connection. As I mentioned, this is commonly seen on coax connections for wide area networks, especially DS3 type WAN links. Because this BNC connection is connecting coax together, you're usually working with a type of media that's a little more bulky and a little more rigid, and it can be more difficult to work with. But because you're using this bayonet type connection that twists in and locks in place, you can be sure that nobody can accidentally pull out one of these connections, because you must untwist this a quarter of the way before you're able to pull it out of that connection. Another type of connector that does not come disconnected very easily is an F connection. It's commonly used on cable television or cable modem type connections. You can see that the connection itself is threaded. So to plug in this coax connection, which is commonly RG6 or RG59, you are threading this onto the connection. So this makes it very difficult to accidentally disconnect an F connection, because you first must untwist all of those threads before the cable can be removed. USB is some of the most common connectors we use these days, and for USB 1.1 and 2.0, we use this style of connector. The standard A plug has the same form factor as other USB standards, although there may be a different number of pins inside of a USB 1.1 or USB 2.0 plug. The standard B plug for these versions of USB is this squared type plug, and this is usually one that you would plug into a printer or some other peripheral. For smaller mobile devices, you commonly see the mini B plug or the micro B plug being used for USB type connections. The USB 3.0 and higher connections have similar but slightly different types of connectors. The USB 3.0 standard B plug, you can see, still maintains that square shape, but there's additional areas on the top of that particular plug. The standard A plug looks and feels exactly the same as the older versions, but as I mentioned, this version has some additional pins on the inside. And you can see the micro B plug has changed quite a bit. We have some additional pins that have been added on if you're using this newer style of USB micro B. A newer standard connector for USB is the USB-C connector. You can see these are relatively small interfaces, as you can see by the side of this laptop, and the USB interface doesn't have a top or bottom. You can plug it in either way, and it works exactly the same regardless of how you connect it. If you're using a mobile device from Apple, you may be using a Lightning connector. This is a proprietary Apple connector that has 8 different pins that you would use to connect your mobile device. This has a number of advantages over the micro USB that you might find on other mobile devices. One advantage is that it has a higher power output, so you can charge those mobile devices even faster. Just like USB-C, the Lightning connector also does not have a top or bottom, so you can simply plug it in and it's going to work either way. This is also a simpler design than micro USB, and it's designed to be more durable than those connectors as well. In an earlier video, we looked at all of the different SCSI interfaces that you might run into, and in the older legacy style of SCSI, you can certainly connect to those devices using many different types of interfaces. Here's an example of a 68-pin legacy SCSI connection that's on a motherboard, and you can see the difference between a SATA drive and those connections, the PATA drive and the very large PATA data connection, and then the SCSI connection on the drive at the bottom. Modern SCSI drives use a serial attached SCSI drive connection, very similar to the SATA type connections you would see on those drives, although these interfaces are slightly different than the SATA drive that you might see. And if you have internal serial attached SCSI devices, you may have an internal high density connector such as this one that might be used for those serial attached SCSI drives. If you're plugging in an external device with SATA, you're probably using an eSATA connection. An eSATA connector has ears on the side and a single square that's in the middle of the connector. This is a little different than the internal SATA type connection that you would have inside of a computer, where the inside is more of an L shape and there's a single ear that's along the outside. On the inside of our desktop computers, we may be connecting older peripherals or maybe connecting our fans to something like these 4-pin Molex connectors. We call this a Molex connector because it was created by the Molex connector company. Technically, this is also an amp mate-in-lock connector, and it provides 12-volt and 5-volt power for these internal peripherals. So if you're connecting older storage drives or the internal fans or other components inside of your system, you might be using this Molex connector to provide that power. The power for Molex is usually provided directly from the power supply. This power supply is a bundle of cables with other connectors on the end for connection to the motherboard, and you can see the 4-pin Molex connectors are there as well.